total internal reflection. Here, air-water interface is shown. This is denser medium, water, and here there is air. This is light source. There are four rays. This ray is incident at 90 degree. So there is no deviation. It means angle of refraction and incidence both are 0 degree. Consider this ray. At this point, there is deviation, means the angle of refraction is greater than angle of incidence. Now, consider second ray. At this point, there is refraction, but angle of reflection becomes 90 degree. So this angle of incidence for which angle of reflection is 90 degree is called critical angle. Now, for third ray, angle of incidence is greater than that of the critical angle and the ray comes back in same medium. So this type phenomena is called total internal reflection. Here, angle of incidence is less than critical angle. Angle of, in this case, angle of incidence equal to that of critical angle. And in this case, angle of incidence is greater than critical angle. Now let's see the definitions. Critical angle, the angle of incidence in denser medium for which angle of refraction is 90 degree is called critical angle. Total internal reflection, the phenomena in which a ray of light traveling at an angle of incidence greater than the critical angle from denser to rarer medium is totally reflected back in the denser medium is called total internal reflection. Now, conditions for total internal reflection. The two conditions are, number one, light must travel from optically denser to rarer medium. And second, the angle of incidence in denser medium must be greater than the critical angle for this kind of combination of media. Now, let's derive the relation between critical angle and refractive index. We know that mu1 sine I is equal to mu2 sine R. Here, for critical angle means I equal to IC, R becomes 90 degree. And mu1 is mu for denser medium. Here we have taken water. And mu2 equal to 1 for air. So if we put these values here, so mu times sine of IC equal to 1 times sine 90 degree. But sine 90 is 1. So mu sine IC equal to 1, which implies mu equal to 1 upon sine IC or sine IC equal to 1 upon mu. Now, let's see totally reflecting prism. PQR is a prism. Here, AB is object. One ray is like this. At this point, there is total internal reflection and it goes like this. Consider second ray. This goes like this. At this point, there is total internal reflection and then it goes like this. So object is AB and its image A dash B dash is formed here. Here, the rays are deviated at 90 degree. This angle is 45, this angle is 45. So total angle will be 90 degree in both the cases. Now, consider second case to invert an image with a deviation of ray through 180 degree. Here, this is object, this is first ray. At this point, there is total internal reflection and the ray passes like this. Then at this point, again, there is total internal reflection and a ray moves like this. Consider second ray. So it goes like this. At this point, there is total internal reflection. Then again, at this point, there is total internal reflection and ray goes like this. So AB is object and its inverted image A dash B dash is formed here. Now consider third case to invert an image without deviation of rays. So here, this is object. Ray moves like this. At this point, there is refraction. At this point, there is total internal reflection. Then at this point, there is a refraction. Consider second ray. it goes like this. At this point, it is refracted. At this point, there is total internal reflection, and it moves like this, and then it goes like this when refraction occurs. And this object AB has its inverted image B dash A dash here. Thank you for watching.